So how does the density structure look like in the ocean interior? You know, you heard about baroclinic compensation. You heard about that the density field, the temperature and salinity fields in the ocean interior are actually an amplified mirror image of the shape of the sea surface. Okay, it's the shape of the sea surface that dynamically drives these currents, the western boundary currents and the currents of the wind-driven circulation. But you can see these currents also if you look at temperature salinity distribution. Okay, and vertical transits. Let's have a look at that. First of all, let's have a look at the structure, how it looks like. So this is the structure of a western boundary current if you cut across it. Okay, you think of, you have a big cake of the ocean and you cut through the cake in terms of the density. And this is how it looks like. This is the Kuroshio current. So you have a sea level anomaly. This is the height of the sea level. And if you cut across the western boundary current, which runs northward, this is the so-called frontal flow here, the sea level increases by 0.5 meter to 1 meter on a distance of, say, 40 to 50 kilometers. It's this strong pressure gradient associated with this change that drives the western boundary. Okay, the density field on the other side is an amplified mirror image. Amplified means that the change that you observe in the location or the vertical location of the isopycnals or isotherms, okay, several hundred meters. So you can see a deepening as you move across the western boundary current of isotherms, isopycnals, also isohalines, the salinity contour by 100 to 500. And this, by the way, is how oceanographers have actually determined the structure and surface speeds of the ocean before we had satellites. Okay, and satellites are not that old. Okay, there were methods by which you could infer the shape of the sea surface by measuring temperature and salinity fields in the ocean. Oh, this is the so-called geostrophic method. Okay, all right. Let's have a look at the real observations now. And this is the Kuroshio. Okay, Kuroshio on the left side shows you a vertical temperature transect. Okay, you have a cake, you cut through it, temperature cake. Okay, and see it goes from the surface to 1 kilometer, and then it cuts horizontal direction is the x-axis, and you know that 5 degrees is about 500 kilometers. Okay, and then you can see the strong slope of the permanent thermocline. See how it's sloping here in this area, and this is exactly where the again you can see that the Kuroshio on one side is very warm water, 20 degrees Celsius. Okay? And this is what we call a front. Front is you move from one side to the other side, there's a big temperature gradient change. So this is now on the right hand side, it shows you the structure of temperature if you cut horizontally. You slice open your cake at a depth of, what does it say, 300 meters. Okay, and if you do that on the left side, 300 meters, if you do it on the left side, is about, you cut through and you end up in 16-degree warm water. Okay, so this is the warm water regions. Okay. All right, and you can see this 16-degree water here on the right hand side. Okay, this is all the water, the warm water, which is actually the eastward of the Kuroshio, okay, which moves along. this section, and then you can see that in the north it gets very, very cold. 2.5 degree water here in the north. Okay, so this is how you can identify the Kuroshio in measurements of temperature. Okay,